ABS light is on. Let's start diagnosing.
Okay, so we're gonna select ABS on a scanner. We're gonna push yes. It's a 2005 Honda Odyssey. And we have the first code on the ABS is a 12-1, which says right front wheel speed sensor failure. Okay, we should always diagnose the first code, because usually the first code is gonna also take care of any other codes. Sometimes, not always, but it's always a good rule of thumb. It also has a 62-1, which is a battery voltage high, and also a 104-1, which is sensor cluster failure. So let's diagnose the first one, right front wheel speed sensor failure. Okay, so it's on the right side of the vehicle, and we're gonna take the wheel off so that we have easier access to get to the speed sensor. So that speed sensor is gonna be somewhere in the hub area of the bearing. Before we actually diagnose the wheel speed sensor, I first want to kind of help you understand why we're diagnosing it a certain way. Here we're going to have a hub bearing. This right here, what I did is I got a magnet, and then I just wrapped a wire around the magnet, and then you see you have two ends, and it will make a little bit more sense once you actually see the actual speed sensor. And also we're going to need a multimeter to diagnose the speed sensor. Okay, so this hub bearing is what rotates the wheel. So when you're going forward or you're going reverse in your vehicle, this wheel is turning as such. Okay, now this is the speed sensor, and the speed sensor is usually located, or what it's doing is trying to figure out the positioning of this hub bearing here. And it's rotating like this, and the speed sensor here is actually producing electricity. Now I wish I can do that for you, and the reason why it produces electricity is just that when you wrap wire around a magnet and you have a rotating device or a rotating component in front of it, it actually starts to generate electricity, and it's generating alternative current. Okay, so in this case here, we're gonna check to see if the sensor is in good shape. And of course, this is just a demonstration, and I just want you to understand how it's built, how the wheel speed sensor is built, so that you can understand why you're diagnosing it a certain way. Let's get started. We're gonna get our multimeter, and we're gonna select the omega sign. Kind of looks like the horseshoe. Then we're gonna get our leads, and we're gonna, I lost my lead here for the negative, so I'm gonna use this to help me keep it in place. Okay. Usually, or most wheel speed sensors are two wires, so you'll see a plug that has two wires, and that's what you're seeing, those two wires right here. And if you notice, check this out, you get a reading. Okay, this is an ohm reading of 0.4, 0.3. Okay, so don't worry about too much about the actual reading, why it's, what specification it needs to be. At this case, we don't know, but my main point in demonstrating this is to give you an understanding that there's continuity, meaning that this wire right here is not broken, because you're getting a reading. Okay, and that's why when we diagnose a speed sensor, we're gonna ohm it out just to see if the component is in good shape. Now, what we're gonna do now is I'm gonna cut a piece right here, and I want you to see the measurement here on the multimeter. Did you see when OL, outer limits? What that says right there is that there's a broken wire inside here, or the circuitry of this sensor is broken. So that's why we're testing out the speed sensor, so that we can see if the wiring is in good shape. Alright, we found the wheel sensor on the right side, and it's located on the actual knuckle or the hub assembly. You can see the CV axle to the left, and you see the wire. It's the only wiring harness going to the wheel. The plug for the right side wheel speed sensor, it's located in the engine compartment area, and it's this orange plug on the pulley side of the engine, which is on the passenger side. Alright, so we got the sensor, the wheel speed sensor on the right side. This looks really good, nothing wrong. So we're doing a visual check on this harness. Everything looks pretty good, nothing looks bad, and so we know that visually it looks like it's in good shape. So now let's test. Okay, so now I'm going to get some pins, and I'm going to place them in the female terminal of the plug. What we're going to do again is, just like we did earlier before when I was doing a demonstration of how the sensor operates or how to test it, that's what we're going to do right now. So we're going to place one lead of the multimeter in place and the other one on the other pin. There we go. Make sure that these leads are not touching each other. All right, now we're going to go to the multimeter and we're going to ohm it out. So again, that omega symbol, like the horseshoe look, and there you go. We get a reading, 3.39. We get a good reading. That tells me so far that the sensor is in good shape. Now, of course, I don't have the specifications for the manufacturer for the sensor or for the vehicle, but I'm not worried about that right now, because obviously it looks like everything looks like it's pretty good. However, if it was a faulty sensor and we didn't get a reading, we got OL, that tells me that this sensor was faulty. So let's move on. Made an illustration here of how I go by testing the wiring harness from the other part of the plug to the ECM, which is this is in the vehicle. Okay, unfortunately I couldn't show you on the vehicle itself. It was really difficult for me to hold on with the camera and do the work. So I hope this helps. Now, the key must be on, but the engine's off. Okay. And then what I did, I placed one lead from the multimeter on the terminal, on one of the terminals, and then the other lead of the multimeter to battery ground. I selected voltage DC, and that's the symbol for the voltage DC. And it's 3.25 volts. So I recorded that reading. Then I went to the other terminal that hasn't been tested yet and placed the lead of my multimeter on the terminal. Then the other lead of the multimeter to battery ground. Again, remember to select voltage DC. There's the symbol so you can understand where to select it on your multimeter. And I got 3.22 volts. Okay. Now, this tells me that the wiring harness and the ECM is working great. Now, I'm not concerned about the measurements in the sense that a specification. That's not my concern. My concern is that I want to make sure that these two readings are not the same. If they're the same, there might be a short in the wiring harness or internally inside the ECM. In this case, we have two different readings and we're good to go. We know that the sensor is in good shape. We know the wiring harness from the ECM to this part of the plug, but on the vehicle, is in good shape. And what I notice is that inside the area where the cavity is at, where this is inserted into the hub, I got a flashlight, looked inside, and I noticed that the wheel bearing had an issue, okay, or the hub bearing. This part of the hub bearing detached itself from the actual assembly, and that tells me right there that this sensor cannot read the rotation of this hub bearing. So we found the problem. It wasn't the wiring that was giving it the code, it was this on the hub bearing that was giving the problem. So that is the procedure for testing a speed sensor of any kind. Okay, this technique that I just demonstrated is a 2-wire speed sensor. If it's a 3-wire, it's a Hall effect sensor, different type of component, that different techniques to troubleshoot. So hope this helps you out, and on the next video we're going to show you how to replace this hub bearing. See ya.